Okay, so on page 8, so just a review of what we finished with yesterday. Variable up high, so we're doing the trig ratio, setting up an equation. Variable up high, so let me just make something up. This doesn't necessarily correlate with those. Variable up high, what do we do? Multiply. Multiply by whatever's in the denominator. I just made some numbers up too. That doesn't deal with any of those questions. Let me just switch it up here. What if it was sine 24 equals 26 over x? Variable down low. Switch your row. So you switch all of that. X is equal to 27 over sine 24. If you forget that, it's simply cross multiplying. You put that over 1. You cross multiply there, set it equal to this one, x sine 24, and then you would divide by sine 24. So if you forget, just cross multiply. That's really why the switching thing works. Okay, cool. Now, the last thing this is good for, trig, well, there's a lot of uses, but for our purposes, the last thing we're going to use it for is finding a missing angle. Nothing really changes. You still set up an equation. You write the ratio. You set it up as normal. There's just one new thing to solve. Hey, by the way, you also need your calculator out, because I want to show you how to do that with your calculator. Okay, now, on this one, what we're going to need when we solve is an inverse of sine, cosine, and tangent. So let me review with you. You've done inverses your whole math life. So as a review, addition. Say it was 3 plus x plus 3 equals 7, and you were trying to solve the equation. You did the inverse operation of subtraction, right? Subtraction to solve. That was the end. I'm just going to put that. You can write subtraction if you want. Subtraction is the inverse operation of addition. Division, a similar way, x over 3. Divided. Well, to solve for x, you do the inverse operation of dividing by 3. So just multiplying. I'll put like times. What about this one? If you have something squared, like x squared equals 9, square root is the inverse. So I'm just trying to get you to think what the inverse operation really is. It just undoes the other operation. They come in pairs. Multiplication, division, squaring, and square root. Okay, so what we're going to need is the inverse of sine, cosine, and tangent. And there's no special word. There's just sine inverse, cosine inverse, and tangent inverse. It's not like there's two different words, like addition and then subtraction. We simply say cosine inverse, sine inverse, and tangent inverse. Any order. Some people say inverse tangent, or they say tangent inverse. Now, what it's going to look like is it looks like it's a -1 power. It's written like this, the inverse operation. Looks like it's sine to the -1 power. That's not what it is. Some people pronounce it like that, but it's really the inverse. Okay, so on your calculator, it is going to be, most of your calculators, it's going to be right next to sine, cosine, and tangent. But you got to hit like the blue button on this one. You got to hit the second button. I'll show you on mine. Let's see here. So mine, you see, it's the blue buttons. So if I want sine inverse, I have to hit second and then sine, and that will give me sine inverse. Now, a few of you, if you have the Inspire, the new calculators, then it is like it's just on there. Like you hit trig and you see all of these 6 pop up: sine, cosine, tangent, and there are 3 inverses. So you hit trig and it should be right there. So you all good with where it's at? No, I'll be around and I can show you. Okay, so now what we're going to do, now we know that, we can now solve the equation. Let's see. Oh, I have a little rhyme to help you with this one. That's right. Here, I say you're already probably filling it out. So if you're trying, these are when you're trying to find the angle. Mm-hmm. Variable apply, multiply. Variable down low, switch around. If you're finding the angle, it's not a curse. Do the inverse. You don't like that one? much of a
I
stretch?
like this.
Yes, that's my favorite one. Switcheroo. Because I was like, I gotta make the
You
switch.
made your own word.
I gotta switch. You gotta make it work. But
You could have used a different word than like down low.
It feels like
Yeah, we
it
always
should be
say-
like a one.
come up with if you
Okay,
come
I'll
up with
come
something better.
I'll tell you.
Under or denominator, something that rhymes with that. Anyways, all right, here we go. So let's do find x in this diagram. X is the angle. They could have easily said theta. They could have also just called it ABC and said find the measure of angle A. Okay, so there's three ways I could really do it. Find angle A, find theta, or they just called it x. Okay, so on x here, we do everything we did yesterday the same. I start with my acute angle. It's that one. It's x. I label the sides. This is the HYP. Across from x is the OPP. The third side will be the adjacent, the ADJ. I identify that I do not have the opposite. So you can leave it, you can cross it out, not even write it, erase it. I have the adjacent and the hypotenuse. So is that sine, cosine, or tangent?
Cosine.
Adjacent and hypotenuse are cosine, yeah.
So,
And you can look at the formula sheet or on your, for our purposes, it's like on page 6 or something. So I do cosine, always of my angle. My angle is x. My angle measure is going to be x. So if you look above it, yesterday it was like sine of 67. Okay, now we don't have it, so it's x. Everything else is the same. Adjacent is 18 over hypotenuse 23. You're trying to find the angle. You need to solve for x, not a curse. You'll do the inverse. So this, it's not cosine times x. Some students write divided by cosine to solve. This is cosine of x. So the only way to get rid of cosine is to do the inverse. What I do to one side, I have to do the other side. So let's like I'm squaring both sides. I'm cosine inverse of both sides. So on the left side, that goes away. They cancel each other out, like square and square root. We're left with x. And on the right side, you put it in your calculator. So you put in cosine inverse. It'll probably do open parentheses for you. Yeah. And then you put 18 divided by 23. Or you do fraction, 18 over 23. So I just want to show you on mine. So I do second, oh, better clear that up. Second cosine 18 by 23. I can close the parentheses if I want. Oh, gosh, I'm in the wrong mode. Whenever I open this up, it changes it back to radio mode. I know, right? So did you guys get, what is it?
I got 38.40.
38, yeah.
5.
Any problem I give on a quiz or test will tell you what to round to. So 38, let's do the nearest 10. 38.5. Okay. Let me ask you if there's any questions on A, and then I'm just going to do one more, because I think we don't need all three. They're all the same type. Let's do B. Anything I can answer on A? Pass.
On a test, we have to write like
This.
no. We have to write cosine.
Oh, cosine inverse?
Yeah, like in the equation. We'll need to find that.
No.
Okay.
Because if you go from cosine x equals this over this, usually it's like a point or two to set it up and a point or two for the answer. So if you write that and then you get here, I'll assume that you did cosine inverse.
do we have to write that?
Just get in the habit. All these are rounded. I mean, well, there are times where you could do sine, cosine, tangent and get an exact value. But a lot of them are rounded, and this just means you rounded. It means approximately equal to. Yeah. I say almost every time because, guys, if you did, like, you could do this for like a 45, 45, 90 or 30, 60, 90. And on those, like, Like if I was trying to solve for this side and I did tangent, you'd get 5. I could do this. I could do that, and your calculator, when you multiply by 5, it would tell you 5. But we also know 45 would just be the same. So, hey, good question. Thank you on that one. Hey, let's do B. So step 1, so I'm solving for x. Down here, started by angle. That would be x. Hypotenuse is here. Opposite my angle is here, this side, 20. The adjacent is the third side. I do not have the hypotenuse. I just like to cross it out. That leaves me with opposite and adjacent, which is which one? Sine, cosine, tangent. Tangent, yeah, that's it. Tangent, I think I mentioned this yesterday. It can never just be TAN and nothing else. It has to be tangent of something. My angle, x. By the way, we don't always, if it's something simple, we don't put it in parentheses, but you really can and probably should put tangent, parentheses, and then put it in. Okay, opposite over adjacent is tangent. That's 20 over 37.
28.4.
Tan inverse to both sides, because I want to get rid of the tangent. What'd you get?
28.4.
28.4. These are all degrees. These are the angles. Just in case you were curious here, the last one would be sine of x equals 15 over 24. Sine inverse, and I don't have my notes on me, but you would get an answer. Hey, one other thing I want to say before we move on to practice is sometimes your calculator can do a good job of telling you you made a mistake. So on this first one, watch this. If I had accidentally flipped them, and I do second cosine, 23, right? Your calculator will say error because it can't do that. You'll learn more about why pre-calculus, but it'll help you out sometimes. So that means you set it up or you entered it into your calculator wrong. In this case, we set it up wrong. The 18 and 23 should have been flipped. So just a nice little thing. Not always, but sometimes your calculator, on the tangents, it won't as much. But sine and cosine can sometimes help you. Hey, you got that, you did something wrong. Yeah?
Wait, is it because one of the legs can't be bigger than the hypotenuse?
One of the legs on...
With the error, it would be saying that the leg would be 23 and the hypotenuse would be 18.
Yes, and basically you'll learn, this is again pre-calculus, you'll learn that sine and cosine values always have to be between -1 and 1. So like 18 over 23 is a number, it's like point something, 0.7 or something, close to 0.7. It's a fraction, it's a number between -1 and 1. 23 over 18 is a number bigger than 1. But yeah, basically that's visually what it's saying. Sounds good. Anything else I can answer?